study.
Okay, so we will talk about this equation. It's problem number 23. This is the equation that has a fraction. When we have equations with fractions, we want them to be kind of looking as one line, not fractions. So what we need to do is find the common denominator and multiply both sides of the equation by that common denominator. Right now, I see something happening here that I need to expand. What do I see, guys? Yeah, what's that?
X minus 2, x plus 2.
Right, how do we call it?
Squares.
The
Difference of squares.
Thank you. Everybody saw that? Right, so it's the difference of squares. So I like this, I like this, I don't like this guy because it's 2 minus x and I need x minus 2. Can I flip it around like this?
Yeah.
Yes, if I move the negative sign somewhere, like I have to either add it
Oh,
here
on the
or
outside,
here or here.
parentheses.
Yeah, I can make that a plus and completely rewrite it as x minus 2. Remember we studied that? That we can't just flip them because you need it. You need to add a negative sign somewhere, and remember it can be here, here, or here, it doesn't matter. For us, it works just to make that positive. It's gonna actually make our job so much easier. All right, so what is the common denominator?
X minus 2.
Minus 2.
And I need to multiply both sides by it. Your problem is that when you write it here, where the denominators go, no, we multiply by it, which is x plus 2, x minus 2, so that visually you see what you're doing. Write it over 1. So that now you see that you multiply this structure and you will be reducing fractions or units like that. And you will multiply the right side by it. Some students don't even write it, but just for learning purposes, we will. Okay. And now what we're doing, we are multiplying this structure by this by this by this. Does this make sense? And whatever, our goal is to get rid of the denominator, period. So if you are still stuck with the denominator, you didn't multiply right. So if I multiply this structure and that, these guys will reduce, and I will use like a light reduction because I'm yet to multiply this by that. So I will have what left from this marriage?
X minus 2.
Mm-hmm. Plus. I only have one. Okay, I'll show you why. Okay. So I've reduced that. These two left. Understood? Does that make sense? Okay. Now you are multiplying, Octavian, the same thing with an existing x plus 2. That's why. This by that. It still exists. Okay? It didn't go anywhere. So I will reduce x minus 2, x minus 2.
To be x
And I'll have
plus
x plus 2.
X
Mhm.
plus
X
2.
plus 2. Good. Equals 40. How does he know that? He just reduces both of them. 40. Any questions? Okay. What's this? Give me a trinomial.
X squared minus 4 plus 4.
You agree?
Yeah.
Okay. What's this?
X squared plus 4x plus 4.
And I'm opening parentheses immediately because I have a plus. If I had a minus, I would ask you guys to do this. But I don't because I have a plus, so might as well just remove it. Can you see me? Right, Nadine? Okay. Equals 40. Okay, let's combine like terms. X squared and x squared. 2x squared. Minus 4x plus 4x disappears. 4 plus 4 is 8. Oh, okay. Equals 40. I'll move my 8 to the right for now. because I'm here to combine my numbers.
Oh.
32. I'm gonna reduce by 2.
Equals,
X
16.
squared equals 16. X equals
4.
Well, be exact, please. It's not 4, it is
4 squared.
No, 4 drive.
Plus or minus 4.
Thank you. But 4 is okay. I'll accept. But yeah. Like if you were like super exact, because negative 4 squared is 16 and positive 4 squared is 16. Does this make sense? That up until this point, this is what we studied, but this we studied like in the first semester. So now we're combining the two methods. Done?